Okay, beta. So today we will discuss theorem 8. Equal chords of a circle are equidistant from the center. Okay. What theorem is saying? If the chords of a circle are equal, what is the theorem? Theorem is if the chords of a circle are equal, then they are equidistanced from the center. Here we have a chord AB, we have taken a chord AB and another chord CD. We have given that the AB is equals to CD, means the two chords are equal here. Okay. And what is the theorem? If the chords are equal, then their distance from the center will also be equal. That can be written as equal chords of a circle are equidistant from the center. Okay. So, beta, we have to prove it because it is a theorem. We have to prove it that these two equal chords are equidistant from the center. What is given here? Given is AB is equals to CD. Okay, it is given that two chords are equal and we have to prove that they are equidistant from the center. First of all, we have to draw the line segment that shows the distance from the center to this chord, and we know that to represent the distance from a point to a line segment or a line, we have to draw a perpendicular. We have to draw a perpendicular from center to the line. A perpendicular line from a point to a given plane or a given line represents the distance from this point to that line. Okay, I mean to say, look here. Suppose there is a point A. There is a point A, and this is a line PQ. Okay, and I asked you to please find the distance. Please find the distance from the point A to the line PQ. Then how will you find it? How will you find it? First of all, you will draw a line segment from there, from this point to this line, and then you will measure the length of that line. For example, suppose one of you draw a line from A to here. Look at this. You draw a line this AB, and you are saying this one is the distance. The length of this line is distance from A to PQ. Ritik, are you getting my point? Okay. And another student draw another line like this, and that student is saying AC is the distance, and one another student draw a line that is a perpendicular from A to this AT, that is the perpendicular, and that student is saying this is the distance. As you can see the length of these three lines are different. We must have a proper way to measure. We can't say this is the distance, this is the distance, this is the distance. We can't go that way, right? So what is the proper way to measure the distance or representing the distance? The proper or right thing is, from point to the line segment, the line must be perpendicular. That line will be the distance. The line that is perpendicular from point to the line, that line represent the distance. Okay. Here AT is the distance. So these two lines are not representing the distance from A to PQ. Line segment AT represents the distance. Why?
This line is
Perpendicular. Okay. Suppose you have to find the distance from this point to that wall. You want to measure the distance from here to that wall. Then how will you find that? Will you join a line from here to that point? No. You will join a line that will be the perpendicular from here to that wall. That will be the distance, because there is a big difference between the length of a line that is going from here to perpendicular to the wall and a line going to that point, right? There is a big difference. So distance is always perpendicular line. Clear? So here now go back to the theorem. Here we have to show कि the distance of AB and CD from O are equal. So first of all we have to draw a line that represents the distance. So we will draw a perpendicular from O to AB. And name it. So OT is the distance from center to AB, right? Similarly, this one is the center. Okay. Similarly, we will draw a perpendicular line from O to CD. That will represent the distance of CD from O. We draw this line. This line is also perpendicular. OS. Okay. And now, as theorem is saying कि if the chords are equal, then the distance will also be equal. So we have to show कि OT will equals to OS. What we have to show? OT equals to OS, and it is given that the chords are equal. Okay. So let's see how we'll show it. Join, beta. Given is AB equals to CD, and we have to prove we have to show OT equals to OS. Okay. So proof. Join OA and OC. Okay. Join OA and OC. OA and OC. Now in triangle OAT and OAT and OCS, we will prove that these two triangles are congruent, and then by CPCT OT will be equals to OS. So let's see how these two triangles are congruent. But it is given that AB is equals to CD, it is given, then half of the AB will equals to half of the CD, because if the two things are equal then their half will also be equal. So let me write it here also. Here AB is equals to CD. This implies that half AB will equals to half CD. Half AB equals to half CD. Half AB is equals to 80. This is the point that must be noted. Ki half AB is equals to 80. How?
AB divided by 2. Because
No. AB is equals to CD given, right? AB equals to CD is given, and half AB is equals to half CD. It is obvious. If the two things are equal, then half will also be equal. This is the obvious. No need whether it is given or not. It is the obvious thing, right? But now I am saying that half AB will be equals to 80. How this?
OT is a perpendicular of AB.
Right? It is given that OT is perpendicular to AB.
So DC.
No, OT is only perpendicular to AB and OS is perpendicular on CD, DC. But it is theorem. It is the theorem we have studied in last or maybe class before the last one. That is the perpendicular from the center divides the chord into equal halves. Means if a line is coming from center to the chord that is perpendicular, that line will divide the chord into two equal parts. Means here AT and BT are equal, and that are the half of the AB. They are half of the AB. That's why we can write, instead of AB by 2, we can write AT also, right? AT. Oh. 80. Can we write BT also instead of A by 2?
Because B is not in the triangle.
Beta,
वैसे B का कर नहीं सकते.
yes, BT is also half of AB because BT and AT both are half of AB, right? AT is equals to CS. Why? Because CS is also the half of CD. By same reason, you will write the reason here, okay? Perpendicular from the center bisects the chord. AT will equals to CS, okay? Now, the further of this part of the question, I will do it here, okay? Now, in triangle OTA and triangle OSC AT is equals to CS. Reason proved above, proved, right? And angle OTA will equals to angle OSC, each 90 degree, right? And OA equals to
OC.
Ritvik.
Yes, sir.
How? OA is equals to OC.
Yes, sir. Equal radii.
Oh.
Radii.
Radii of same circle, right? Okay?
Yes, sir.
So by a congruency rule, these two triangles are similar, congruent. Can you tell me the rule by which they are congruent? OTA
Angle
Hypotenuse and
RA RHS.
OTA is congruent to triangle OSC by RHS, right? Right angle, hypotenuse, and this, this side, right? Right angle, hypotenuse, and side, RHS. So by CPCT, we can write कि OT is equals to OS, right? CPCT. Okay. So this is it proved, right? Note it down, beta. So let's move to the another theorem, that is the inverse of the previous theorem. The chords of a circle which are equidistant from the center are equal. This is the converse of the last theorem. It is saying if the chords are equidistant from the center, then they must be equal. They will be equal. Okay. It is saying ki beta, this one is a chord and this one is another chord. O is the center. It is given that they are equidistant. Equidistance means the perpendicular from the center to this line and perpendicular from the center to this line will be equal. Means OP is equals to OQ. These two lines, these two are equal. It is given, right? And we have to prove. We have to show AB is equals to CD. Okay, just the opposite of the last theorem. So beta here, similarly by joining OA and OC, here in the, you can see AB and CD are two chords, and it is given that they are equidistant. That means ki OL will be equals to OM, because OL and OM are the distance, na? And it is given that the distance are equal. That means ki OL and OM are equal. That is given. OL will be equals to OM. Now join OA and OC and look in the triangle. Look at in the triangle OLA and OMC. Okay. OL is equals to OC given. OA is equals to OC, radii of the same circle, and 90-90. So by RHS, these two are congruent. Which two triangles are congruent? OLA and OMC. These two triangles are congruent. Triangle OLA will congruent to triangle OMC by RHS, right? So OLA congruent to OMC by RHS. Now you can say कि AL is equals to CM by CPCT. But here we have to show that CD is equals to AB.
Multiply AL CM
By 2. Because if the AL is equals to CM, then double of AL will be equals to double of CM. Obvious things, or you can say by axiom or postulate. If the things are equal there, double will also be equal to 2AL is equals to 2CM. And 2AL is equals to AB because AL is the just half of the AP. AL is just half of AB. Why? Because this line is a perpendicular, na? And perpendicular always divides the chord in half to equal half. So 2AL is equals to AB and 2CM is equals to CD. Now it is proved. Okay. Okay, beta. So please remember it, and if you want to make a short note, you can note it. Only theorem. The chords of a circle which are equidistant from the center are equal. Okay. Okay. So here we have another theorem, that is, there is one and only one circle passing through three given non-collinear points. Let's first try to understand what the question is here, what the theorem is. Theorem is, if there is three non-collinear points, there are three non-collinear points, 1, B, C. You can see there are three non-collinear. You know what are non-collinear points? The points that are not in the straight line. Look at these 3 points, P, P, Q, R. Now you can see these 3 points are on the same straight line, right? So if the points are on straight line, same straight line, right, then they are collinear. Then they are collinear points. And if the lines are not on the same straight line, they are non-collinear points. So here A, B and C are three non-collinear points, okay? And what the theorem is saying, कि only one circle can pass through this. Only let's try to understand this theorem more with the example, with some example. Let's start with one point. Let's first start with only one point. If anyone asks कि how many circle can you pass through this point? Let there be a point Q, and someone is asking कि how many circle can you pass through this? Then, as this boy is saying कि infinite. The answer is right. But why? Why infinite? How you deduce this? How you go to this?
Circumdistance.
Beta, you know कि let O is the center of a circle and you draw a circle whose radius equals to OQ, whose radius is equals to OQ. definitely that circle will pass through Q, right? Similarly, you have a point P here, okay, and you draw a circle whose radius is equals to PQ, whose radius is equals to PQ. Then in that case, that circle will also pass through Q. Similarly, you can take infinite points, right, here and join that point to the Q and take a radius equals to that line and draw the circles. Conclusion is कि a point is a point can have a infinite points from which it is a equidistance. What I am saying, if there is a point Q here, right? You have a point Q, and I ask how many points from which Q can be equidistant. So you can say, sir, infinite points. From the infinite points, it is equidistant, right? Or I hope you understand by this example also. We can take infinite points around Q, and we can draw a circle from joining that point to Q and taking radius equals to that, right? Suppose someone asks, let's move to the 2 points. This one is about 1 point. Suppose anyone asks, there are 2 points. A and B. Then how many circles can pass through these 2 points? Then you have to find all those points from which these 2 points are equidistant. Again infinite. Again you may ask how, sir? Let's join AB. Okay. AB. Let us draw a perpendicular bisector of AB. What? A perpendicular bisector of AB. And when you take any point on the perpendicular bisector of AB, any point on the perpendicular bisector of AB, suppose you take a point here, okay, and this point is M. You can see कि AM and BM are equal. AM and BM are equal. Similarly, if you take a point here, T, AT and BT are equal. You may ask how. Look, AT and BT. This one is the perpendicular bisector, so we can take it here as a right angle. Look, 90-90. This in these 2 triangles, ATM and BTM, you can see that the triangle ATM and BTM are congruent triangles. How? AM is equals to BM because this line is the bisector, and these are 90-90 or TM common. So by side angle side, these 2 triangles are congruent, so AT is equals to BT. Similarly, you can prove that triangle A and this triangle AM, I have given the name M there also. So let me erase that. S. Similarly, you can prove that triangle ASM and BSM are congruent. So AS is equals to BS. So, what the conclusion is? Conclusion is that A and B are equidistant from S. A and B are equidistant from the T. Similarly, whenever you will take a point on this perpendicular bisector, A and B will equal from that point. Okay, A and B will be equidistant from that point. So we can take infinite point on this line. So we have an infinite point from which A and B are equidistant. So you can draw infinite circles. Suppose you take a center here. You take T as a center and A as a radius. When you draw a circle, that will pass through A as well as through B. That will pass through A as well as through B. Why? Because AT is equals to BT. So that circle will pass through A as well as B. Na? Are you getting my point? Okay, beta. So how many circles can pass through 2 points? Infinite. Because there are infinite points from which the 2 points are equidistant. So let's come to the theorem that is about the 3 non-collinear points. How many circles can pass through 3 non-collinear points? So we had to search out from how many points 3 non-collinear points are equidistant. Like this. Right now, we have to find out from how many points 3 non-collinear points are equidistant. If there are 2 points, suppose there are 2 points from which 3 non-collinear points are equidistant, then we can draw 2 circles from 3 non-collinear points. If there are infinite points from which 3 points are equidistant, we can draw infinite circles from these 3 points. And if there is only 1 point from which these 3 are equidistant, we can draw only 1 circle from these 3 non-collinear points. And as we can see, our theorem is already saying there is one and only 1 circle can pass through the 3 given non-collinear points. That means there is only 1 point from which the 3 non-collinear points are equidistant. Okay. So let's see how we will prove it. How we will prove it that only 1 point is equidistant from these 3 non-collinear points, and so only 1 circle can pass through 3 non-collinear points. Let's see. See in this figure, beta. Okay. Suppose we have A, B, and C. These 3 are 3 non-collinear points. Okay. A, B, and C. And we have to prove that only 1 circle can pass through these 3 points, and so it means that only 1 point is there from which A, B, C, and are equidistant. So first draw the perpendicular bisector of AB. What we will do? We will draw the perpendicular bisector of this. Okay, we have the 3 non-collinear points now. We have 3 non-collinear points. A, B, and C, like this. Join AB and BC. Okay. Then draw the perpendicular bisector of this line. What? Perpendicular bisector of AB as well as BC. Perpendicular bisector of BC. Okay. As you can see here. PQ is the perpendicular bisector of AB and RS is the perpendicular bisector of BC. And as you can see, these perpendicular bisectors are meeting at a point, right? They are meeting at point O. Okay? They are meeting at point O. Now, let's see, suppose this point's name is M and this point's name is T. Now you can see कि OA is equals to OB. How? Because triangle OAM and OBM are congruent. Right? OAM and OBM are congruent. How? This one is the perpendicular bisector. That means here is 90 and here is also 90. And AM is equals to BM because this line is bisector and OM is common. So OMA and OMB are two congruent triangles. Okay. Then by CPCT, OA is equals to OB. Similarly, triangle OBT, what? OBT, this triangle beta, this triangle OTB, okay, and OTC are also congruent by similar way, है 90 90, here is 90 and here is 90, OT is common, CT is equals to BT because RS is bisector. So we can say that OB is equals to OC by CPCT. So now you can see that OA is equals to OB and OB is equals to OC. So you can see that O is equidistant from A, B and C. O is C. Now, so we can draw a circle from O as a center and OA is equals to radius. That circle will pass from A, B and C, all 3 points, because OA, OB and OC are equal. So whenever we draw a circle taking radius equals to OB or OB or OA or OC, that circle will pass through all 3 points A, B and C. Now a question arises, can we take another point other than O as a center, and can we pass a circle through these 3 points other than O as a center? Means ki we have taken O as a center and draw a circle radius equals to OA, and that circle is passing through ABC, right? So can we have another point other than O from which, when we are going to draw a circle taking that point as a radius, that circle passes through ABC? For that point must be equals to that point must be equidistant from A, B and C, na? But there is no point other than O which is equidistant from ABC. Okay. You may ask, sir, how? How you will show कि no point other than O is equidistant from A, B and C. So we will show it by method of contradiction or supposition, assumption method you can also say. Suppose beta, here it has written suppose there is another point, there is another point OQ. What?
Okay.
there is another point, sorry, O dash, which is equidistant from AB. There is another point, suppose we have supposed that there is another point other than O that is equidistant from AB and BC. AB and BC, that means that is equidistant from A, B and C. So that suppose if O dash is that point which is equidistant from A as well as B, that means O dash must lie on the perpendicular bisector of AB. Because if any point is equidistant from 2 points, that point must lie on the perpendicular bisector of that, the line segment joining those 2 points. Okay. O dash must lie on this perpendicular bisector. Okay. So let's see, suppose O dash is lying on the perpendicular bisector, so that will be equals to this, and O dash also must lie on the perpendicular bisector of RS, because that point must equals to B and C also, na? Equidistant from B and C also, so that must lie on the perpendicular bisector of BC also. Okay. But we have heard, and it is a theorem in a maths, that two lines can intersect at most at 1 point, not more than 1 point. And we have another already point O, where these 2 points the perpendicular bisector of these 2 lines have intersect, means PQ and RS have intersect at O. So we cannot have any other point than O which is equidistance, right? Because if O dash is the equidistance, that will lie on this line, and if O is the equidistance from these two, this will also lie, this lies on this line also, and that is equidistant from all these three, means that will be the common of the intersection of these 2 lines. That point will be the common intersection, like O. And we know that 2 lines cannot intersect more than 1 point. So we cannot have any other point other than O. So what is the conclusion? The conclusion is we have only one point which is equidistant from the 3 non-collinear points. So only one circle can pass through 3 non-collinear points. In short, let me explain once again in short. How will you show it? Only one circle can pass. You will take 3 non-collinear points, right? You will join them, okay? And you will draw the perpendicular bisector. Suppose the points are A, B and C. You will join the perpendicular bisectors, draw perpendicular bisector, and the points where the perpendicular bisector are intersecting, that will be the center of that circle. Suppose they are intersecting at point T, you will take T as a center, and radius equals to either AT or BT or CT. It depends on you, because AT, BT and CT are equidistant. So T will be the center. You can take AT as radius, and you will draw a circle that will pass through A, B and C. Okay, and we will show as we know the 2 straight lines can intersect at most at 1 point, so there will be no any other point from which A, B and C are equidistant. So we cannot draw any other circle that is passing through A, B and C. Hence only one circle can pass through A, B and C. Okay, beta? This will be the homework. Okay. The homework is prove theorem 8, equal chords of a circle are equidistant from the center by yourself, and similarly you will prove theorem 9, and 10. Okay, this theorem is very important actually. This theorem is very important कि only one circle can pass through 3 non-collinear points. Okay, I will check it tomorrow. Okay. Okay, so we will discuss further in next class.